So day two, we are going to investigate what alternating current is really all about. Okay, we start out with solving the homework problem, and uh, to nobody's surprise, or should be to nobody's surprise, the outcome is that you come out with a sine curve. Okay, solving the problem is essentially coming up with a sine curve. And a sine curve is called a wave curve because it looks just like a wave. Okay, and the importance of that sine wave is that it takes on values that are both positive and negative. So there's no constant value associated with a sine wave. There's a values that keep repeating itself themselves over and over again. And the repeat is time variant, okay, which means that the sine wave is dependent on time. And in fact, AC circuits depend on time. When we create a circuit that's an AC circuit, many times we are asked to do a time variation analysis. In other words, what goes on at what time and what goes off at another time, and is there any type of interference between one signal to the other? These are all time varying functions that could happen in an AC circuit. Okay, so we'll start off first with understanding how we create that sine curve by using a generator. Now, a generator is normally associated with DC output, but how we configure the generator is it's more natural that it comes out with an AC circuit, AC current, alternating current. But once we have that wave, then we have to label it somehow. We have to label its voltage and we have to label its current. And there are a number of ways few ways that we can label it. We can label it as peak values, we can label it as average values. But more importantly for AC, we label them as what we call root mean square values, or RMS values. The reason we do that is we go back to our original thinking that electricity is a way to distribute power, okay? And the best way to measure power in AC circuits is to use an RMS value that then can associate the power that you use in AC circuits to an equivalent power that used in a DC circuit. Okay, so RMS is the most important value, but always check to see if you're given the uh, uh, one of the three major uh, meanings of voltage. Does it ever give you a peak voltage? Does it give you a peak-to-peak voltage? Or does it give you an RMS voltage? And the same for current. Does it peak, RMS, or peak-to-peak? Okay. So then finally, we generalize on waves. What makes up a wave? Believe it or not, other waves make up a wave. Okay, this is proven to be scientifically correct, that if you have a sine wave is made up of a lot of other smaller sine waves. And if you have other types of AC waves like a triangle wave or a square wave, many different types of AC signals, they're also made up of a bunch of sine waves put together in such a way so that they add up to give you a whole square wave, triangle wave, or a sine wave. Okay. So I have a number of homework problems that we're going to go over, but we'll go over them tomorrow, give you the answers. You are to attempt them tonight or sometime today, but have them done by noontime tomorrow so you can get credit for doing the work. Okay. So let's get going and let's have some fun with this.